So let's go to number 15. Number 15 is saying we have z1 equal to negative 1 plus I, and z2 equal to negative root 2 minus root 6I. 15a, find trigonometric forms of z1 and z2. B, write the product z1 and z2 in the Cartesian and the trigonometric form. So this number, you can find it on, it is number 10, Lab 2014. So number 15a, we have z1 equal to negative 1 plus I, and you have z2 equal to negative root 2 minus root 6I. The question is to find trigonometric form of z1 and z2. Remember, for z1, its trigonometric form to be r1 into bracket cos angle 1 plus I sin angle 1. So we need to find modulus of z1, argument of z1. So the modulus of z1, it is one which is r1 to be square root of negative 1 squared plus 1 squared. So the answer is root 2. So the modulus of r1 will be equal to root 2. Then finally, what is tan alpha 1? To be equal to b over a. So tan alpha 1 will be equal to b, that's 1 over 1. You know that we don't use signs, we don't use negative sign. So that is tan alpha 1 will be equal to 1. Alpha 1 will be tan inverse of 1. So alpha 1 will be equal to pi over 4. So we're going to check the location of this complex number. We use trigonometric circle. So now our a, it is negative, which is negative x-axis, and our b is positive, which is in the positive y-axis. So it will be in the second quadrant. It is here in the second quadrant, and you know that in the second quadrant our angle equal to pi minus alpha. So our angle 1 will be pi minus alpha 1, which is pi minus pi over 4. So our angle 1, the answer is 3 pi over 4. So which means that z1 equal to root 2 into bracket cos 3 pi over 4 plus I sin 3 pi over 4. That is for z1. So let's go for z2. z2, if you remember, equal to negative root 2 minus root 6I. So we need also to express this algebraic form into polar form. So z2 will be equal to r2 into bracket cos angle 2 plus I sin angle 2. So now r2 will be equal to the modulus of that one, that is square root of negative root 2 squared plus negative root 6 squared under square root. So which means that our r2 modulus, that is root, this is 2 plus 6, which is root 8. Root 8, that is 2 root 2. So R2, the answer is 2 to 2. So I'm going to find the argument angle 2. Tan alpha 2 will be equal to b over a. Tan alpha 2 will be equal to, that is root 6 divided by root 2. You know, from what you have, like root a divided by root b, this is the same as root a over b. So which means that tan alpha 2 is root 6 over 2. Tan alpha 2 is root 3. Then tan inverse alpha 2 is tan inverse of root 3, which is 60, pi over 3. So alpha 2 is pi over 3. After that, we're going to check the quadrant that is located where so we're going to see, we use trigonometric circle to know the quadrant that is that complex number is located. So it is located. So now we use trigonometric circle to know the location of that complex number. So our A is negative. It's because we have a negative root 2. We have a negative root 2 here. So our B also is negative. So it is here in the third quadrant. And you know that in the third quadrant, you know that angle equal to pi plus alpha. So which means that our angle 2 will be equal to pi plus pi over 3. So meaning that our angle 2 will be equal to 4 pi over 3. So which means that Z2 will be equal to, our Z2 will be equal to 2 root 2 into bracket cos 4 pi over 3 plus I sine 4 pi over 3. So that is Z2 and this is Z1. I hope there is no any question. We have Z1 here and you have Z2. So B. So now B, it is asking to write Z1 times Z2 into polar form and the Cartesian form. So what do you do when you have Z1 times Z2? Z1 times Z2, it is R1, R2 into bracket cos angle 1 plus angle 2 plus I sine angle 1 plus angle 2. That's how we write Z1 times Z2. So meaning that Z1 times Z2, the answer is R1. What is R1? R1 is root 2 times R2, 2 root 2. Then into bracket cos. What is angle 1? Angle 1, if you remember, it is 3 pi over 4. Plus angle 2, which is 4 pi over 3. Then plus I sine 3 pi over 4 plus 4 pi over 3. So which means that Z1 times Z2, it will be equal to root 2 times root 2, that is 2. Times 2, that is 4. Into bracket. Cos, I need to find the LCM here, it is 12. 12 divided by 4, that's 3. 3 times 3, that is 9. 12 divided by 3, that is 4. 4 times 4, that's 16. 16 plus 9, that is 25. Then plus I sine 25 pi over 12. So that is Z1 times Z2 into polar form. So what is the Cartesian of this one? So you can use the calculator to see if you will not get the decimal. If you find that you are getting a decimal, you use trigonometric formulas to get what? The value of that one. Let's first try for using calculator. We check for cos of cos. This is 25. Pi over 12 is 15. 25 times 15. So it means that we need to find cos 25 pi over 12 and we find sin 25 pi over 12. So let's continue to express Z1 times Z2 into algebraic what? Algebraic form. So this is the polar form. For algebraic form, Z1, Z2 will be equal to what? So we're going to express this one into into algebraic form. Yeah, you know when you have like cos of 2 pi plus alpha, this is the same as sine alpha. This is the same as cos alpha. When you have sine of 2 pi plus alpha, also this is sine alpha. Because you know when you have cos A plus B, the answer is cos A, cos B, minus sin A, sin B. So meaning that cos of 2 pi plus alpha is cos 2 pi cos alpha minus sin 2 pi sin alpha. But cos 2 pi is 1, sin 2 pi is 0. So the final answer is cos alpha. So sin, you know when you have sin A plus B, this is sin A cos B plus cos A sin B. So then now sin of 2 pi plus alpha is the same as sin 2 pi cos alpha plus cos 2 pi sin alpha. So sin 2 pi is 0, cos 2 pi is 1. You see finally it is sin alpha. So that's, so, and also what is 25 pivot curve? This is the same as, it is the same as 2 pi plus pivot curve. It is the same as that one. For example, if you find the same, SM is 12, here is 1, 12 divided by 1, that's what curve, times 2, that's 24, plus pi c, it is the same as 25 pi pivot curve. So instead of using this, I'm going to use this one. So meaning that cos of 25 pi over curve is the same as cos of 2 pi plus pivot curve, which is the same as cos what? Cos pivot curve. Even on sine of 25 pivot curve is the same as sine 2 pi plus pivot curve, which is sine pivot curve. So it implies that now implies that z1 times z2 is the same as 4 into bracket cos pivot curve plus I sine pivot curve. So what do we need? We need to convert to find the value of cos pivot curve. So what is cos pivot curve? Cos pivot curve is the same as cos 4 pi over curve minus 3 pivot curve. So which is cos, do you agree with me here? Because 4 pi minus 3 pi is pi. So now here it is cos by 4 1, that's pi over 3 minus pi over 4. We use the formula when it is minus, that is cos pi over 3 cos pi over 4 plus sin pi over 3 sin pi over 4. So meaning that cos pivot curve, the answer is cos 60, it is a half, cos 45 is root 2 over 2, plus sin 60 is root 3 over 2, sin 45 is root 2 over 2. You see now, cos of pivot curve, the answer is root 2 over 4, root 2 over 4, root 6 over, that is root 2 plus root 6 divided by 4. So let's go to sine. Let us go to sine. So what is sine pivot curve? Same applies, it is sine pi over 3 minus pi over 4. So which is sine pi over 3 cos pi over 4 minus cos pi over 3 sin pi over 4. So what is sin pi over 3? That's root 3 over 2 times root 2 over 2 minus a half times root 2 over 2. So meaning that sine pivot curve, the answer is root 6 minus root 2 over 4. So then finally, Z1 times Z2 in Cartesian form or in algebraic form is 4 into bracket, the value of course, root 6 plus root 2 over 4, plus I into bracket, root 6 minus root 2 divided by 4. You see 4 is common, you take 4 out of the bracket, so remain with Z1 times Z2 equal to root 6 plus root 2 plus I into bracket root 6 minus root 2. So this is Z1 times Z2 into algebraic form. I hope there is no any question. So let us stop from here. We meet next time. God bless you.